Good day, everyone. Uh, I don't have to be mentioning my name all the times, but I have to, I think, because there are every possibilities for one to forget my name. So my name is Ibrahim Kabir J as usual, and I'm a physics teacher, mathematics teacher at the same time, chemistry and so on and so forth. In the last class, in my previous class, I discussed on a topic like vector and finding the resultant of vectors acting in different sides, its opposite directions, and I also talk about finding the resultant of vectors when two vectors acted in the same directions. I also analyzed how where the resultant will focus on, and I made mention that if a vector is greater than the other, then the resultant will definitely be on its own side. And I also discussed on when the vectors acted perpendicular to each other, and that is 90 degree to each other, and we analyzed some examples, and a lot of discussions were made, and I hope it was so clear to everyone. And I also talk about how one can get the directions of the resultant vector when you or she calculated, and it was also analyzed fully, and it was somehow in details, which I give a work for the listeners or for the viewers to like go and check so that they can make some exercise by themselves. So today in my class, I think I'm going to discuss on the main resolution of vectors, where this time around it's not the vectors that are given. What we are given is just the resultant of the vectors, then break it into components. So looking at my diagram on the board there, what I have is a diagram with y-axis up here, with the x-axis here. Remember in the previous class, the forces or the vectors that are acted here and here combine together to form a single vector called resultant vector. That's what we discussed last. But in this case, we are given the resultant and are asked to find the components of the vectors that combine together to form the resultant R. So there are only two components we normally have. Number one is vertical component, and number two is horizontal component. So the vertical component of this resultant R is F y equals to R sine theta. We call it a vertical component of the resultant. R. So this is what we have at the vertical, or as the vertical components of the R. Next, I'm going to have just the horizontal component, which is the vector along the x-axis, which is f of x equals to r then cos theta. This is the horizontal component of the resultant vector R. So these are the two given components we have that combine together to form our R. So that's what we have. That is Fy equals to R sine theta and Fx equals to R cos theta. So these are the two components that we normally have. The vertical component is R sine theta only if the angle subtended, or the angle of the resultant, is to the horizontal. If this angle is to the horizontal, then our vertical component will be R sine theta, and our horizontal component will be R cos theta. While if the angle here, theta, is to the vertical, then our Fy component, that is the vertical component, will be r cos theta instead, while the horizontal component will be r sin theta instead. So automatically this formula is for theta is to the vertical, or to the horizontal, sorry, is to the horizontal, is to the horizontal. It's going to be somehow like this again, which is Fy equals to r cos theta, and Fx equals to r sin theta. This could also be the same thing as r cos it's okay, I think we can leave it this way. So what we're going to have is just r cos theta, but we can still take it further because this is the same thing as r. It's going to be like r bracket, sorry. So this vertical component as r cos theta can also be written as r sine bracket 90 minus theta, and also r cos 90 minus theta. So this is what we have, and this is theta is to the horizontal, the vertical, sorry, is to the vertical. So ladies and gentlemen, what's most important there is just the information, or let me see, the explanations I'm giving about the whole thing. I said we are going to find the components of vectors when a resultant is given. And in my diagram here, what we are given mostly is just the resultant. We're asked to find vertical component and horizontal component. What you will notice is where the angle is subtended. So the angle is to the horizontal. When the angle is to the horizontal, then our vertical component as Fy will always be equals to r, that is the resultant, sine theta. And the horizontal component will be f of x equals to r cos theta, which is named the horizontal component. So these are the things we have as vertical component, horizontal component, when the angle theta is to the horizontal, while it is Fy equals to r cos theta and Fx equals to r sin theta, which can also be written as r sine 90 minus theta, and here r cos 90 minus theta when the theta is attached to the vertical, that is this place, which is 90 minus theta. So this is all I can say about the resolutions. This is just the skeletal of the whole thing. Now we are moving down to the examples related to what we just discussed. Please stay tuned and see what's going to happen in the next clip. Thank you very much. I remain Kabir Ibrahim. Go for a short break.
Got it. Stay on it.